Hello friends, this is continuation of 2024 question paper part 3. Here the 41st question is the correct IUPAC name of the following compound is. So they have given a molecule and they are saying what will be the correct IUPAC nomenclature for this. Okay, first we have to know that here CHO, which is aldehyde group, and there is a nitro group and methoxy group here. So first of all we have to start naming from the aldehyde, since it is a since we have to give the aldehyde as the highest priority, which is formyl, also called as formyl, and hence it is for the highest priority, hence it is the parent as a benzaldehyde, which is called as, this is CHO, this is benzaldehyde, this is the benzaldehyde. Okay, then if we start the naming here, 1 2 3 4 5 6, this is the numbering. Okay, you can also tell me that why we have to start numbering like that and why not like this, by considering 1 this 2 3 4 5 6, which numbering is right. So according to this it will be 4 methoxy, 2 nitro benzaldehyde according to the first case, for the first case, and according to the second case it will be 4 methoxy, 6 nitro benzaldehyde. Okay, according to the second case, but according to the IUPAC nomenclature, always we will give priority to the less numbering carbon, means we will make the here 4 2 and here 4 6, it is the lowest set. So here 2 and 6 is there, so this is the lowest set, so we will prefer according to the IUPAC naming is this one. Hence we will make the aldehyde group as the parent chain and start and give the preference to first preference to this and start numbering from like this and we will give this as a methoxy and this as a nitro, since it is a ortho and it is a para. So let's see the options. Since first is 4 formyl, 3 nitro anisole, since it is a formyl means it is a aldehyde group, but they are saying that it is a 4 formyl, means they are numbering like here 1, hence 2 3 4, so this option is wrong, since we have to make a aldehyde as the first priority and give start numbering from here 1 2 3 4. Okay, 4 methoxy, 3 nitro benzaldehyde, so they are telling the 3 nitro, since it has a 2 nitro here, it is a second position, it is in the second position 1 and 2, but they are telling 3 nitro, hence it is also wrong. Okay, next 4 methoxy, 6 nitro benzaldehyde, already we have discussed about this, this is 4 6 set, hence it is a highest set or largest set, we have to consider this as a 2 and 4, not as a 4 and 6, so this is also wrong. Hence 2 formyl, 5 methoxy nitrobenzene, here they are telling that a nitrobenzene as a first position, so they are giving the parent chain as a nitro, but this is also wrong, hence this is the all options are wrong, hence it is the grace marks, it is given as a grace, so here the options are all are wrong, so correct option is this 4 methoxy 2 nitro benzaldehyde is the correct option. Okay, let's look at the IUPAC naming of the cyclic compounds like a bicyclo. Okay, here they are given a structure, and they are saving the to give the IUPAC naming to this compound. Okay, for this compound we have to, let's see the IUPAC naming. The compound is like this, like this is the compound they given. This is the compound they are given. So we have to start numbering like this. First we have to see the where is the bridge carbon and start numbering from there. Okay, first we have to move from larger cyclic, since it is a bicyclic, it is a tertiary, sorry, not tertiary, it is a cyclo propane, and this is the 4-membered and 3-membered. This is 3-membered ring and this is 4-membered ring. So that bicyclo, since two cyclic rings, and start numbering from highest carbon, and means longest chain, 1 2 3 4, and this is 5. Okay, there is a 4, but we have to consider this fused rings. These 4 fused rings considered as a 0. Consider these both fused carbon are considered as a 0. Hence, there are 2 carbons. So consider the longest or the largest cycle, and write the number. Here 1, and this, consider this both fused carbon as a 0 and pentane. This is the IUPAC nomenclature, bicyclo 210 pentane. Also we have to discuss some of the other problems, so that this is the fixed question in every exam. It will be, let's consider this. Okay, now we have to first identify the fused carbons. This is the fused carbon and this is the fused carbon, or bridged carbon. We have to also tell us these both are bridgehead carbon. These both are bridged carbon, and here 1 2 3, just only 3 carbons are there, and here 1 2. Hence we have to consider from here 1 2 3 4, right? 5 6 7, this one 8. Okay, and start numbering from the largest chain or largest branch. 1 2, here we have to consider this as a 0. Okay, 1 2 3 3, and consider this as a 1 2 2, and now it will be 0. Let it will be 0, and here there will be the 1, hence it is 1 octane. Right here bicyclo, since there are 2 cyclic rings, hence this is the bicyclo 321 octane, like this. And I will give another problem, and you have to solve this and comment in the comment section about this answer. Try yourself and comment below the answer. Okay, so the ultimate answer will be here 210 pentane, since this is the 0, 210 bicyclopentane. Okay, next one is, there is a Z, means gem, means same. Okay, this is the trick. If they are given the E, then it is the opposite. If they have given Z, then it is Z means gem, means same. This is the trick for Z and E nomenclature. Okay, Z means same. But2-ene reacts with the Br2 in CCl4. So they are giving the bromination to the cis but2-ene. So we have to first write the what will be the cis 2 butene. So C double bond C, CS3, CH3, H, H. This is the cis. or we can also tell Z. Since we can't call this as a cis, since it is in a double bond, it is fused with a double bond, we can't call this as a cis, since it is not can't able to rotate. So we have to name it as a Z. Okay, Z but 2-in is reacts with bromine in CCl4. We will get, since there is a 2 carbons, we write the 2 carbons, and for here we will make the domination as a Br 1 carbon, and then this is not right. Once again we will consider this as a 1 carbon, first carbon, and we will make here as a bromine Br, and consider this as a second carbon Br, and CH3 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 H H. Here the bromination will take place in transform, like the anti, since always the bromination will take place in an anti manner, anti attack will take place, anti attack. So bromonium ion will always attack, make a anti attack to cis but2-in Z to make this as a trans. So by considering this, this is the inward and this is the outward. So this is the R configuration and this is the S configuration. So 2R 3S 2,3 bromo, hence 2R 3S 2,3 dibromobutane. This is the correct answer. Why this is the wrong? Here there is a 2R and 3R, since both are R, hence it is wrong. This is both are S, hence wrong. Here R SS, so it is the equal proportion, it is also wrong, since this is the right. Okay. The molecule with a n chiral centers can have the maximum of dash stereoisomers. Hence they are telling about the maximum chiral centers. So chiral means it involved R and also S. So for the maximum, hence it is a not n, since they are about asking about the maximum chiral of the n. So n square is also wrong, since they are asking about the maximum. So that each chiral center have the theoretical maximum number of 2 into 2 into etc. So there will be n number of the maximum chiral centers. So 2 into n raised to n, 2 raised to n is the correct. This is also wrong, since 2 into n will be the give the only 1, but here these all gives the only one number. 2 into 1 it will be 2, 2 into 2 it will be 4, like this, but here 2 raised to n is the right answer. Okay, next the aromaticity, which will following the aromaticity means exhibit the perfect aromatic character. Okay, for the aromaticity we have the Huckel's rule, which follow 4n plus 2 rule, right? It will be odd. Okay, here there will be 1 2 3, hence this is the odd number, hence it will also follow the aromaticity. And here 1 2 3, this is also odd, hence it is also follow aromatic character. Here 1 2 3, this is also odd, and there will be sp2 hybridization. This is sp2 hence planar, hence it is also aromatic. But here 1 2 3 4, there are 4 double bond, means it will have the even number of the electrons, hence it will be anti-aromatic. Hence 1 2 3 means here 1 2 3 it will be the correct option. Here 4 is mentioned, it is wrong. 4 is mentioned, it is wrong. 4 is mentioned, it is wrong. Okay, Identify the correct order of the reactivity in electrophilic substitution reaction. So electrophilic substitution, here there will be some of the students will confuse that here they are asking the electrophilic substitution. So electrophile means which will have the electron withdrawing group, they will say, oh, this is the electrophile, this is the, so that they will mark like that. But they are saying that electrophilic substitution means electro will substitute which will have the more electron density. Electrophilic substitution will take place to the nucleophilic center, so nucleophile. So we have to make which benzene ring have the most electronic density, most electric density. So here for nitrobenzene, it will have the withdrawing capacity like N double bond O minus. Hence they will withdraw like this. Hence here benzene capacity will be lesser since withdrawing nature is there by the minus M. If we will get the chloro Cl, it is also withdraw by the minus I effect, so it will also less, but here from minus I, but it will have a more withdrawing nature. Okay, then there will be the CS3 which will donate, so that since it is will be donating nature, CH3 it will donate, hence plus I effect. Therefore since it has a minus I effect, minus M effect, so it will withdraw from the resonance, hence it is from a mesomeric effect. So it will always have the lowest means less electron density on benzene, so that it will make the less electrophilic substitution reaction, so it will be less reactive. Hence the fourth one will be the last. So here one is, but here they are telling 1 is greater than 2, but it is wrong since it is a giving, hence it is a electron donating group, it will be first, hence 2 is first, 2 1 then 3 then 4. Yes, right, since 4 is nitrobenzene which is last, and here the plus donation will taking place from the plus I effect since it is in first position, and then there will be the high moiety electron density moiety benzene, it is in a second position, and then there will be the Cl because it is withdrawing from the minus I effect, so it is in the third position, and it comes the fourth position as a nitrobenzene. So this is the right answer. Okay, in 47th question, here it is the 47th question. Here they are telling that which of the following orders is the correct for the stability of these carbocations. Hence they are asking here, telling about the stability of the carbocations. For the knowledge purpose I am just stating tertiary is greater than secondary is greater than primary for the carbocation stability. Why? Since carbocation means there will be the formation of a plus charge on a carbon, means it is a electron deficient. If it is a electron deficient nature, then it always stable it by withdrawing the electrons. So it will always it is always make that I want electrons. So it always want the electrons. So it is always tends towards the which will give its electrons. Since nitrogen is nitrogen will donate the electron, since here oxygen is more electronegative than nitrogen. If we come to electronegativity power, oxygen is most electronegative. What is electronegativity? It will not release its electron easily, it will make the electron as a tight bonded, so that oxygen will not easily give its electrons to the neighboring p orbital. But here there will be the empty p orbital is there, means here there is a empty p orbital since carbocation is formed, and there are a lone pairs. Since here N CS3, since here there is a lone pairs are there, since it is a positive nature, here it is a empty p orbital, since here electrons will donate like this, hence it will be the more stable. Why not oxygen? Since oxygen is a most electronegative group, hence it will not easily donate its electrons, like the nitrogen. So comparatively, nitrogen is greater for the stabilization of this carbocation. Hence, and there is another case which will be the like this positive. Here there is a resonance stabilization. Here there is the resonance stabilization, but here there is no resonance. Hence, there is no electron transfer take place like this, because here it is the sp2 hybridized. Hence, it is a filled p orbital, but it is a vacant p orbital. Hence, we will can't able to. So it is sp3 hybridized orbital, since here 4 orbitals are there. Since it is already filled orbital, there is no vacant orbitals. Hence, it will not able to transfer or resonance its orbital. Hence, it is not a planar orbital also. Hence, it will be least stable than that of this, and this is least stable than that of this. Hence, if we come to here, 2 is greater than that of 1, and that is 3. Hence, 2 is greater than 1, 2 is greater than 1, and then 3. It is correct answer. 3 is last and 1 is last. Okay, which of the following orders is the correct for the stabilization of the carboanions? Means carbanions means here primary is more than secondary is more than tertiary. Since carboanions are the negatively means electrophile. So for this, it already there is a electron density, high electron density. So this will not prefer for the withdrawing of the electrons, but it will always try to donate the electrons. So already it is already electron rich density. So it is try to move its electrons. Since we'll see here, there is a this carbon is called as this carbon is called as always allylic carbon. Yes, allylic carbon. Since it is a allylic anion, since there is a double bond and then is a carbon and then is a minus charge. Since it is a most stable than these two, right? This is most stable than these two, and so this is always in the first priority for the charge transfer, like this. Since it is a allylic carbon, it is most stable. And then if we see this, here there will be the 2 means 1 2 3 4, there is 4 electrons, hence it is forming a anti-aromaticity. Since it is a even number, even electrons, then it is a anti-aromatic, and since it is a means it is a the three-membered cyclic ring, hence it is always there is a steric hindrance. There will be a steric hindrance in this first carbon. But if we come to the third carbon, here there will be the 6 electron system, which will be the aromatic, and also it is a 5-membered ring, 5-membered cyclic ring. Hence it will be the most stable ring. So that always 2 is greater than 3, and 3 is sorry yes, 2 is greater than 3 and 3 is greater than that of 1. So here 2 is greater than 3 and 3 is greater than 1. This is the stability order. Okay, 49th question. Here they are asking about the carbon stability for the intermediates. Okay, here they are the singlet, triplet, both, and both are equally stable, and stability of the carbons is unpredictable. So if we see the here, they are already given the structures also. So it is very easy to us, since carbon contain both electrons in only one orbital. But in triplet, the orbitals are delocalized. Hence, since here orbitals are delocalized, hence here there will be the repulsion will take place. Repulsion is there here, and here no localized orbital in the singlet. But here in triplet there is no repulsion and grounded. Hence, it has a lower energy than that of the singlet. So triplet has the lower energy and it has a grounded and ground electrons, and there is a delocalization also take place. Here delocalization will take place. hence it has a delocalization, it has a its electrons are in the ground state, and also it has a lower energy, hence always triplet is the stable carbons than that of the singlet, hence 2 will be the correct. Okay, next will be the nucleophile. If we see this here, there will be the quaternary ammonia is there, quaternary ammonium salt. This is, hence this is the quaternary ammonium salt. It is not as a it is always it contain the positive charge in it. Since it contain the positive charge, hence it will be the least electrophile. So since it is a least electrophile, but here if we contain here n, there is a lone pairs here, one lone pairs. If we contain here, there will be the in all cases there is a lone pair, but in here there is no lone pair and there is a positive charge also. So this is act as a electrophile than that of the nucleophile. So that we will contain this as the answer. And if we come to here, the electrophilic aromatic substitution proceeds through. Since here they are telling about the electrophilic aromatic substitution. So since there is a electrophilic aromatic substitution, it is always prepared in the sigma complexes. Since in sigma complexes there is a word called aranium ion, or else there is a word called Wieland intermediate, which will be formed. Hence this Wieland intermediate is also already shown that it is a sigma complex. Hence you already know that in a benzene there is no electrophilic substitution, and means it is processed through not through the benzene. Hence carbon is not there, hence free radicals is already not there. So sigma is the only. If sigma and if there is a pi, then there is a confusion. But here sigma is only bond which will transfer the electrons. Hence there is the electrophilic aromatic substitution will always proceed through the sigma complexes. Okay, then 52 question. Which of the following will undergo SN1 reaction faster? So for the SN1 there is the formation of the carbocation. So that for carbocation tertiary is greater than secondary is greater than primary. So that tertiary, so that which have more electron density. So here two phenyl rings are there and it is a tertiary carbon, so that it is more more faster rate of the reaction than that of the others. So here there is the CS3, hence it is second position. This is the first position and this is the in the second position and this is in third position. So this is a CS2 and here CS3, which is the primary carbon. Hence it is a secondary, hence it is a third position and it is a fourth. At least rate will be here. So this is the fourth one will be the correct answer for this. Fourth option is the correct. Which of the following catalyst is used in a Sommet-Hauser rearrangement? So that in Sommet-Hauser rearrangement there will be the okay, we will write the reaction also. In this is the there will be the CS2 and tertiary quaternary nitrogen is there. These quaternary ammonium salts are converted into stable. This is quaternary is converted into tertiary. This is the reaction of the Sommerfeld Hausner rearrangement. Hence there is a rearrangement will be took place from the quaternary to tertiary. Rearrangement will be take place. Hence here they are telling about the which catalyst is used. If we see the options are like this. Here first one is the alkali metal amide, and second one will be the sodium hydroxide, and then potassium hydroxide and aluminum chloride. Here aluminum chloride is the Lewis acid. It can't act as a base, since it contains the base, so that there will be the rearrangement will be taken place. so it have to the base always, also it act as a catalyst. So to work it has to be done. But here aluminum chloride AlCl3 is the Lewis acid, so here it is not used as. Then there is a potassium hydroxide and sodium hydroxide, both are just bases, it is not the catalyst. So there is the only one option, that is alkali metal halide, which is like this, NaNH3 per ammonia. So this is the right answer. And here there will be the, for another grace question, I will also add that there it is always prefer the stereoselective, means sorry, it is always prefer the regioselective, since it is a ortho position, always the rearrangement will take place in the ortho position. So it is Summit reaction is a Summit Hauser rearrangement will be the regio selective towards the ortho, it is regioselective towards the ortho. So it will be the fourth option is the right option. So 54th question, that which rearrangement is taken place. So we already discussed that Somit-Hauser rearrangement. So it is uh, the quaternary ammonium salt is converted into tertiary ammonium salt, so that it is not here, there is no formation like that, hence it is not there. And also we have discussed that it is the ortho, since it is a regioselective, hence there is no ortho selective is there. It is always, it is look like the Somit-Hauser rearrangement, but it is not, because here there is no ortho para will take place, only in the benzene rings Somit-Hauser rearrangement will be take place. And for the on research, it is for the carboxy groups, but it is, there is a carboxy group, but there is no nitro group, so it is not it is also, it is also not fixed, since it will be also nitro and carboxy groups, nitro and carboxy groups for non-nitrogen, so it is also wrong. And for the summit hydrogen, it will always prefer the ortho position, so that is there is no benzene, so that is no ortho positions, and there is no functional group. And if we come to the Smash rearrangement, it is the inter nucleophilic aromatic substitution, so it is also wrong. Hence all the last option is Steve's, it is right. Steve's rearrangement will be convert the quaternary ammonium salt into rearranged tertiary ammonium. So here there will be 1-2 shift will take place, so that Steve's rearrangement and Summit Hauser rearrangement both are make only one job, that is it will convert a quaternary ammonium salt into the rearranged tertiary amines. But here there will be the rearrangement will take place like this, by using some of the catalyst. And also there is a regioselective, means there is a ortho selectivity there in the there in the Summit-Hauser rearrangement, but in that of the Steve's rearrangement there is the 1-2 shift will be take place. So this is the main difference between these two. And one research will be the nitrocarbonyl groups, and for small rearrangement will be the intranuclear aromatic substitution. So if we come to the 55 question, the starting material in Mursi olefination reaction is, means here already given that olefination means there is a last product will be olefin, means there is a here there is a formation of the alkene group will be taken place. So this is the mainly for the carbonyl compounds, there will be two carbonyl compounds will couple each other so coupling of the reaction will take place of the two carbonyl, it may be aldehyde and ketones, to form alkenes complex, to form the alkenes. So if there is a formation of the alkenes, then there will be no starting material of the alkenes. Then if these both are the wrong, means there is no dienophile. Dienophile is there in the Dean-Alder reaction. So dienophile is already there in the Dean-Alder reaction. So that in there is no amine, so the option will be 2, which is the carbonyl compounds. So there is the coupling of aldehyde and ketone will take place. Two carbonyl compounds will couple to form the alkenes. So this is the McMurray olefination. Okay. Next question will be 56th question. What will be the major product of the following reaction? So here the reagent will be the selenium dioxide is used. So that here there is a compound. So that will be the reaction will be CH3, C double bond CH3, and this reaction can also write like this also, like CH3 and H. So here selenium dioxide and base is used. So here the options are given like this, so that here the hydrogen is replaced by the, here the CH3 is replaced by the CH3OH, and here the both CH3 is replaced by CH2OH, so alcohol, and also here this CH3 is replaced by CH3OH, and here this CH3 is replaced by, means below the CH3 is replaced by alcohol CH3OH. So here we can differentiate that. For the one question, these both are same, since here the CH3OH both are replaced by the alcohol, and also here CH3OH both are replaced by alcohol, and here only one CH3 is replaced by CH2OH, and here also one CH3 is replaced by CH2OH, and we know that diol is we will get in presence of the osmium tetroxide, in presence of osmium tetroxide, means OSO4. In presence of osmium tetroxide we will get the diol, but in presence of selenium dioxide we will get only CH3 is converted into alcohol, so methyl to alcohol take place. But here it is the sterically hindered CH3 is converted into CH2OH, but here the free, there is no sterically hindrance, because there is the another group will be hydrogen here, so that it is not sterically hindered, so that the right answer will be 2. It is not that stable, then that of the this, so that the option 2 will be right answer. Here there will be sterically hindrance will be take place, but here it is not. Okay. Next will be the ozonolysis yields to formaldehyde. So the organic compound will be took place the ozonolysis, then formaldehyde will be formed as one of the product. So from which organic compound it will confirms that the presence of the formaldehyde they are asking. So the first option will be the methyl group. Always a methyl group will be the CH3, so that there is no formation of the formaldehyde, because in formaldehyde there will be presence of the aldehyde. So methyl group is not present, because here C single bond C will be taken place. Here C single bond C will be taken place. In vinyl group also there will be the like this. In vinyl group, what will be the vinyl group? Vinyl group is like a CH2 double bond. Hence, here there is a presence of the double bond, and next of the carbon will be the called as vinyl group. And in C triple bond C, there is the presence of the there is the presence of like the carboxy acid and ketones. In the cleavage of the C triple bond C, there is the presence there will be the oxidative cleavage, and there will be the product will be carbonic acid, or there will be the presence of ketone. And in the two italic double bonds, there is the presence of the terminal like the vinylic group, but that is not surely can form the formaldehyde. So according to these statements, here methyl group was also gone, and in C double bond C there is formation of ketone and carboxylic acid, so that it is third option is also gone. And in the two ethylic double bond, there is the formation of the vinylic group, but not surely there is a formation of the formaldehyde. So that according to the by removing three option, vinyl group is the right answer. So that by forming the terminal there is formation of the terminal methylene group, which is double bond CH2, which is vinyl group. There is the formation of the formaldehyde as one of the product. Okay, next one will be the BOC. The BOC group is the is of which of the protecting group. So here they are telling that which BOC is called as the protecting group. So BOC is always the protecting group of the amines. So it will be always protect the amine. So BOC is called as the here tertiary butyl oxy carbonyl group, means butoxy. Here butyl B, oxy means O, and carbonyl means C. So tertiary butoxy carbonyl group. This is the correct option. And butyloxy group is not there, since there is no carbonyl group is there. Hence here there is a carbonyl but there is no tertiary. And also here carbonyloxy group, which is not there of the carbonyl group. So that the correct option will be first one, will be the correct option. So next option is the next question will be 59th question, that is the correct synthetic equivalent for the synthesis of NO plus. What is NO plus? NO plus is the nitrosyl ion. So how to prepare the nitrosyl ion by using these reagents? So that HNO3, simple HNO3 can't make the nitrosyl ion, so that it is also gone. So and then NaNO3, only simple NaNO3 can't make the nitrosyl ion without the reaction, so it is also gone. And here the procedure like the concentrated HNO3 plus concentrated H2SO4. We already know that this mixture is used for the production of nitronium ion, which is NO2 plus. So that it is also gone. Here they are asked just of the nitrosyl ion, which is the NO plus. So that here what we will get here, NaNO2 plus HCl, which will gives us to NaCl plus HNO2, right? HNO2. So by the HNO2 we will get NO plus. So this is the perfect reaction. So that here option number 3 will be right answer. So next will be the reagent used in surplus asymmetric epoxidation is. So here there is a AlCl3, anhydride AlCl3. So this is used in the Friedel-Crafts alkylation. So it is used in the alkylation. And benzoic acid, this is used for the epoxidation, but it is used for the not in the surplus asymmetric epoxidation, but it is used for the another type of epoxidation called as non-asymmetric. It is used for non-asymmetric epoxidation. Okay, then next will be the titanium tetra isopropoxide. So it is used in epoxidation for the surplus asymmetric epoxidation. So it is the right answer. So not only this, but by the using the diethyl tartrate, also the combination titanium tetra isopropoxide plus here diethyl tetroxide, the diethyl tartrate is used. This mixture is used for the surplus asymmetric epoxidation, but here DCC is used for the coupling reactions like the peptide coupling. This is used as in peptide coupling. This is used for the peptide coupling. So that DCC is not there. So the right answer will be the titanium tetra isopropoxide is the right answer. Okay, the next one will be the easiest because we already know that which one is the chiral center. So here there is the no chiral centers because it is a since it is a chiral means here all are the same. Here if we come to here also cs2 cs2 cs2, so it is chiral. So it is a chiral. And if we come here, it is also cs2 for these both group, and for this it is also cs2, for this it is also cs2, so it is also a chiral. So if we check the chirality, we always know that only A will be the chiral centers, because here there will be the ch group is there. That means C means here there will be the sp3 hybridization, and here there will be sp2 hybridization for this cs3, so that A will be correct answer. Okay, next give the name of the following molecular orbital of the 5 carbon system. Here 1 2 3 4 5 carbon system, and there will be 2 internal nodes are present. These are the 1 and this is 2. So there are 2 internal nodes are present. So for this question we have to just make 2 plus 1. Calculate the internal nodes and add for this 1, and we will get 3. This is the correct answer. Just make this like this. This is the easy trick to calculate the molecular orbital for the 5 carbon system. To just calculate the node and then add to the 1. So it will be psi3. And here name of the following reaction. So here Norris step 1 reaction. For Norris step 1 there is always the there will be sigma means yes, sigma cleavage will be take place. Sigma cleavage will be take place, will be mandatory. And for Norris type 2 there will be the there will be gamma hydrogen there is gamma hydrogen absorption will be take place. It will be mandatory. And for the Paterno-Bucci reaction there will be always 2 plus 2 photo cycloaddition will be mandatory. So here there will be formation of the oxytens. So always oxygen will be mandatory. If there is a formation of the oxytens, then it will always 90% it will be Paterno-Bucci reactions. But here there is no formation of oxytens, but there is a formation of the cyclo 3-membered cyclic ring. And there will be the, and here also we can identify that there is dienone. There is 2 double bond which is conjugated, and there is a sp3 hybrid sp2 hybridized carbon, sorry, sp3 sp3 carbonized hydrogen atom is there, since it is oxo dimethane rearrangement. Okay, if n parallel atoms p orbitals overlap in the pi manner in a monocyclic array, the lowest molecular orbital has no nodes, and it is called as so they are telling that there will be the overlap manner in a p orbital, there will be the overlap manner of the pi orbitals will take place. So p orbitals overlap will be taking place in the monocyclic array, so that, and also there is the lowest molecular orbitals and no loads, so that it is all the properties of the Huckel system. But in the Mobius system there will be the nodes will be present in the Mobius system, and Mobius system and the anti-aromatic both are included. And here there will be here there will be 2n plus 1 rule be there, and here there will be just 2n rule is there in the Mobius system, so that these both are wrong. Hence if we aromatic system is also right, but but here they are telling about the rules, so that Huckel system is first priority, and then there will be the aromatic system, so that we will get the priorities as Huckel system. Okay, Next question will be the which of the following statement is incorrect. So here there is the first option is the furan is more reactive than that of the pyrrole, and then some of the pyrimidines are found in nucleic acids, and next will be electrophilic substitution in pyrrole occurs in 2 and 5 positions, and fourth is the pyridine is less basic than that of the pyrrole. Okay, uh, here we will come to know that always pyrrole is greater than that of the furan, which is greater than that of the thiophene. Okay, in for the electrophilic aromatic substitution, for the electrophilic aromatic substitution, so that according to this pyrrole is more than that of the furan, but here furan is more reactive than that of the pyrrole, so first statement will be the incorrect. Okay, next we will see some of the pyrimidines are found in nucleic acid. Yes, pyrimidines are found in the nucleophilics. Okay, electrophilic substitution in the pyrrole occurs at 2 and 5 positions. Yes, it is also correct. In the pyrrole, there is a 2 and 5 positions for electrophilic substitutions, and pyridine is less basic than of the pyrrole. It is wrong. Pyridine is like this. Here, already it is aromatic. So, this both lone pairs are free to attack on the attack on the hydrogen or uh, some other electrophile center, since these both are the more basic, these lone pairs, so that it is also wrong. So here two statements are wrong, so you can choose anyone, and sometimes it is also called as the grace marks also. Okay, here the structure of the um, pyri, pyri, pyridine. Yes, pyridine. Here for the pyridine, the structure will be this. This one is the right, because this is called as the pyridine, and this is called as pyrimidine, and also this is called as piperazine. So you have to know about these structures. In future also this can be asked. So this is the fused ring, and this is the wrong, and this is called as a piperazine. So here they are asking about the pyridine, so it is also wrong, and this is pyrimidine, so it is also wrong. So right option will be this. Here is the right option. And for the 67 question, digneton is a digneton is a it is a steroidal saponin which contain the sugar residues. It contains the sugar residue. So there here the glycoside is the correct option for this, since it contains the sugar residue. Here glycoside is the contain the sugary molecule, but in case of the lipids is the it is a glycosidic sugars. It is also but not like that glycoside. It is the main component, so it is a simple fatty like structure lipids are. And if we come to protein is the it is peptide backbone. Peptide backbones are called as proteins. Peptide backbones are called as proteins. So number of the peptides will form the proteins. So alkoxide, alkaloid. Alkaloid is the it contains the N containing, means the nitrogen containing backbone. So it is a basic structure of the nitrogens. Okay. Next is the reagent used in von Boron method is. So von Boron method. So we know that the von Richter method in the second or first sem of the MSc, but here they are asking about the von Richter, von Boron. So here there in von Richter we are used HCN and NaCN is used there, but in von Richter, so we can eliminate these both. These are the wrong. So there is a compression between BrCN and CH3CN, so that the correct option will be the here cyanogen bromide. It is called as cyanogen bromide will be the correct option. And next will be the 69 question. A metastable ion has so always metastable ion has the higher energy, so that we can neglect these both, which is lower and here lower. So the option will be the higher kinetic energy than normal molecules and higher potential energy than normal molecules. For which kinetic energy used? For kinetic energy used for the movement, so that it will be also wrong. So always it has the higher potential energy than that of the normal, since they possess the internal energy, because they possess internal energy, hence they can have higher potential energy than the normal molecules. Okay, for the 17th question, if the chemical shift difference is equal or slightly higher than that of the coupling constant, then which of the following will be occurs? So here they are telling that the coupling constant is slightly higher, so there is little amount of the increase in the coupling constant, and they can also involve the equal. So that here for the first order reaction, always in the first order reaction, always coupling constant will be delta V is more higher for the coupling constant, so that first order is wrong. And we note that for the first order spectra there is a simplified spectra, but for the second order spectra it is not simplified, so that it is also first order, since simplified spectra is wrong. They are just telling the properties of first order here, so it is also first order reaction, AX spectra, hence it is also wrong. So here there is a non first order spectra, means it is a second order spectra. So for second order spectra, delta V is slightly greater than or equal to that of the J. Since this there will be the complex spectra, since delta V is slightly greater than that of the J, hence there will be the complex spectra will be apparent.